Good afternoon. Thank you for attending this class. We barely start function point analysis last week, but we started over and I have updated the slides. So in case you have printed it, the later slides may be changed. So I generally encourage you to use soft copy. Okay, for one thing, it saves the environment, and I believe even using PDF, you can easily do some highlighting or add notes to help you to study. I do that all the time when I'm studying some people's academic paper in PDF file. So you can do the same by using my PDF file. If you bring a notebook computer, a tablet, you probably can highlight it or add notes to help you to study. So soft copy probably would be a very good thing for you to do. Not just it's a good thing for the environment of saving paper. So function point analysis. We are in the chapter of doing software measurements. Okay, so we try to measure software, and function point analysis is an approach that measures software to help us estimate how much work there is to write a system. So it's a little bit unlike some of the measurements we have before. For example, in the alcohol measurement, we have written the code. We try to measure its quality by whether it's lack of cohesion. So if it's lack of cohesion, that means you're trying to put unrelated code together in a method or in an object. So that's not very good. So, but some of the measurements we have learned last week is for quality, okay? But these measurements we're doing is more for the size or complexity. So how big is the system? How complex is the system? So it has benefits that good benefits, okay? So this function points analysis, we can use it to measure software. The approach 1 and approach 2, we actually have studied earlier, a few chapters ago. WBS stands for work breakdown structure. So if you have a system, we try to break it up into small components. Once it's small enough, then it's easy for us to understand, then we can estimate it. And Delphi method is that we may have a few experts working together and then they try to independently give an estimate. Okay, so maybe for this task, some estimate 2 days, some estimate 3 days, and so on. So, and usually that's not too bad. But let's say if somebody estimate it is 1 day, another person estimate is 7 days, then is many times difference. In that case, we will have some discussion, and then they would go around. They would make after some discussion, explaining why it should take long or why it should take short time. Then they vote again, or they write down their new estimate. That's called the Delphi method. Another method is, okay, for each component, we look at an optimistic case. So in the best case scenarios, we can do it in 2 days. In a typical situation, a medium, okay, we think it's 3 days. In the worst case, it may be 10 days. Okay, so 2 days for O, 3 days for medium, and 10 days for pessimistic. Pessimistic means worst case scenario. Okay, that takes very long. So you can apply this calculation and divide by 6. This formula basically is give equal weight to the optimistic and the pessimistic one, same weight, and then give the medium or most likely case 4 times the weight. And then in our case, if this is 2, this is 3, and this is 10, after doing some calculation, our estimate will likely be something like 4. Okay, my guess is it will be like 4 or 4 point something. So this would be our estimate that is used for this one. But these two estimates have some weakness. Okay, because it's not very systematic to do things. Well, it's not totally random, but it's not totally systematic. Well, at least there's one problem. Your estimate and my estimate may be different. So it depends on what kind of experts you have. For example, if your team member, if all of them are very optimistic people, so they always make mistake by thinking it takes very little time, okay, then even their pessimistic case estimate will still be overly too optimistic. So this will not be very reliable, okay? So these two methods of estimating software development effort has a problem that is subjective to people. So some people, everyone would come up with different answers, even for the same system where they are trying to do. So this is okay. This is a drawback, and we've looked at OO measurements by these two guys, include Alcom, okay, but they measure other quality. They measure software quality more than the size, okay. And can we use line of code, number of lines of code, to measure software development effort? Yes, we can do that. We can use it to measure the effort to write the software, but we only have this number after the software project is done, after we have finished the coding. So that is not very useful, because we want to be able to estimate at the beginning of the project rather than at the end of the project. So that's the motivation we want to use function points analysis. So this is some strengths and limitations of function point analysis. So we'll show very shortly that it allows different experts to follow the same method, and it will come up with the same estimate. So in that sense, it is objective. So it's no longer subjective to who is doing the estimation. So that is the main strength of function point analysis. But the drawback is it requires some effort. So more work needs to be done before you can come up with the estimates. And also, it is more useful for software development, but you cannot use it to estimate software maintenance effort, because software maintenance depends on other factors. For example, how well the code was written, and how experienced is the person with programming, with maintenance, or with the and also the maintenance programmer. Shh, someone's talking too loud. Please lower your voice. Okay, please. So we cannot use FPA, function point analysis, to uh, measure software maintenance effort. Okay, to estimate. Okay, so how to use function point analysis? They try to break up user functions into 5 kinds. So it will be one of 5 kinds. Okay. There is the ILF, internal logical file. It is a function about data owned by the system you are creating and updated by the system you are creating. And EIF is external data that the system does not own, but is from the environment. So the environment will provide, for example, another system will provide some data to this system. So this system will be reading data belonging to some other system. So that we call this function EIF function. Okay, and the blue colors stands for data, more data, but the red one are for the transactions. So this is more with the operations that we have to do. For example, if we are reading in some data, okay, then this function will be called external input. And if we are sending data out in a data transaction, then we call that EO, okay, and for external output. And there's another one called external query. That means data will come in and go out of the system. Okay. So these are the user functions. And now let's look at the data. So some of the data, for one, the smallest unit of data is perhaps a data field. Okay. For example, a student ID, account number, account type, or in a university registration system, the user's major program or the student name. Okay, so each one is a data element type, and depending on how you're going to use it, if you're going to use it in a transaction, then the data field will be grouped together as a file type referenced, FTR. Okay, if it is going to be used in a data function, then we call it record element type. So that is how. So the data field, the concepts of data field apply to all 5 kinds of user functions. Remember, in case you have forgotten, you can also go back to here to decide what is the purpose of one function. Okay, so and this is for the data. Okay, they group together as RET, or if it's a transaction, it's grouped together as a FTR. Okay, so I guess the name may not make a lot of sense to you because these are somewhat older terminology, because function points evolved near the ends of 70s and early 80s, and data processing is quite different at that time. Okay, so what is a data element? Well, for example, a radio button, a checkbox, command buttons, graphical image, sound, or data fields, input or output, and acknowledgement messages or other notification messages. Each one is a field, a DET field, okay, data element type. And so this approach, function point analysis, you will try to identify all the user's functions, and then for each user functions, you do some counting. You do some counting to count how many fields are there and how many groups are there. Okay, how many the grouping. So in case of this ILF and EIF function, this is data functions, then we're grouped in together. Okay, so this DET is the number of fields, and this is the number of grouping. So we see that as the number of fields increases or the number of groupings increases, we rank that particular user function. Okay, so we try to make, so if the small number of fields and also small number of grouping, we call this function as low complexity. So what are these things for? So each kind of user functions has a table like this, okay? And so each kind has a table, and then in the end, we will calculate. So this refers to the complexity. So if we have, let's say, one EI function, okay, if it's low complexity, it will contribute to 3 function points. If it's high complexity, it will contribute 6 function points. So after you identify all the functions in your system that is being built, then based on the number of fields and number of grouping, you decide whether it's low, average, or high complexity. And then by counting them, you will find a total number of function points. So that's roughly how it works. So let me save it in a recording, in a file, and then next we will go on to specific examples, okay?